Today you're going to see slab formwork setup. Loose clay dugout. Sides buried with sand. Huge stones placed for the entrance. The slab poured. A stone facade built. More piles drilled. The slab waterproofed. Stairs formed. And the entire basement covered for good. Now, we start with setting up the string line through the middle of the basement because this slab isn't flat. It's got 3 slopes, one from the front to the back and 2 more dropping to each side from the center, just like a roof. We frame the perimeter with 10x5s, setting slab angles and a base for the top boards. The first sits 12 centimeters lower than the walls, ready for another 10x5 and 2 centimeters formwork boards. Once the perimeter's set, we move to the middle, starting with tripods for the adjustable props. Tripods go in first, and if you caught part 2 of the basement build, you'll remember we laid OSB on the floor to make this step easier. Then the props slot into place and lock in, and on top we add fork heads, giving us a stable cradle for the beams that will shape the first slope of the slab. Once the center beam is in, we start the second layer of the frame. One for each side using the same 10x5 timber. This part takes the most time because the first ones need the most adjustment to get both dimensions right, since we'll use these pieces as templates. And we'll need plenty, because this slab needs a lot of support. We cut each one with a circular saw, and they don't have to be millimeter perfect, since the formwork boards on top will even everything out. What matters is that they sit solid, follow the slopes, and give full support across the frame. Once all the beams are cut to size, we start setting them in place. Forming the base for the top frame, each beam is set just 30 centimeters apart. That tight spacing keeps the formwork locked in position, stops the boards from flexing, and makes sure the slopes stay exactly where we set them. It also spreads the load evenly across the props and center beam, so nothing is overstressed. When we walk and work on top, the frame stays solid, and once the concrete goes in, there's no risk of twisting or sagging. For the bottom beam through the middle, we used a double 5x10, so the top frame can come in from both sides. The frame's coming together nice, almost like a roof. But before we go any further with the formwork, we've got the backhoe loader back on site to sort the outside walls. First job, clear out the loose clay that's fallen in since this hole's been open. We dig right through it until we reach the natural sharp sand underneath. Exactly the solid base we need. We're lucky it's here because that layer will act as natural drainage for the basement, so we won't even need to install a separate system. And skipping that saves a lot of time, a lot of work, and a lot of money too. Once all the clay's out, we get pure sand delivered to fill the sides of the basement. The first load's a big one, 22 tons, and we're gonna need plenty more lorry loads before this fill is done. We start loading the front bucket of the backhoe loader to get the sand closer to where we need it. Space here is tight, massive piles of clay from the basement dig on one side, and the basement itself on the other, so every move has to be precise. We pile the sand with the loader's front bucket, then switch to its back bucket to drop it into the gaps along the walls. And we're not just dumping sand in. We're mixing it with the clay. Along the wall, we lay a 30 centimeter thick strip of sand for drainage, then fill the rest of the space with clay. If we didn't do it this way, we'd need 3 times more loads of sand, and that would be a big waste when this method works just as well. Of course, it's a bit more manual labor. When you drop clay in, some of it ends up on top of the sand, and you've got to clear it off with a shovel. But that effort is worth it because that strip of sand right by the wall is doing the real work here. Clay would just trap water and press against the concrete, but sand drains it away, keeping the basement dry. Clay also expands when it's wet and even more when it freezes, which can put huge pressure on the walls. And when it dries out, it shrinks and leaves gaps that let water back in. By keeping clay away from the wall and using sand instead, we cut all those risks, and at the same time the cost stays down while the structure stays protected. We filled the front bit so we can keep building the stone facade. There was no way to lay more stones from down in the trench. And with all the sides packed, we now have solid access to both the facade and the top of the slab. That's important, because the rest of the work, boards, rebar mesh, and finishing the slab, all has to be done from the top. With the last sand filled in, the main framing section is finished. And it's time to finish the rest. We're setting the remaining props and adding the extra support rows. These extra props are going in only now after the top frame is set. That's the moment when we can see exactly how the slopes line up. Each one has to be adjusted to the right height because the frame is running on a slope, not flat. Every prop ends up a little different. Putting them in now makes sure each one fits perfectly under the frame. We also need more of them to spread the load. With just the middle and the sides, the weight would push unevenly, too much pressure in certain spots. And remember, this frame has to carry a lot, nearly 8 cubic meters of concrete plus all the rebar mesh and the boards on top. By adding the rest of the props, the frame gets full support across the whole basement. With the last supports locked in, the frame is finally complete. And now we can move on to the next step, laying the boards across the top. We're using the same marine plywood from the wall formwork. Big sheets, 1.5 meters by 2.5. They're thick enough to hold the weight of the concrete, and one board covers a lot of area. That means fewer joints and less chance for concrete to leak through the formwork. We're using these for the main sections where no cuts are needed. But for all the small cuts and odd shapes, we switched to OSB. It's a much cheaper material to waste, even if it does leave that nasty pattern on the concrete. It's a budget choice. Save the good marine ply for where it really counts, because those sheets will be used again on future projects. Once all the boards are in place, we seal the gaps with expanding foam. It keeps the concrete mix inside, stops honeycombs from forming, and stiffens up the board edges, making the formwork solid and ready for the next stage. All the boards are in place and the formwork is sealed tight. The next step will be adding side panels to hold the slab's thickness, keeping the concrete on top where it belongs. But before that, we're jumping to the entrance, shaping the slopes out of big stones. Since the backhoe loader is still on site, we're using it now to set the stones in place, before sending it off for a month. Only the front of the basement will stay visible, finished with a stone facade. From both sides of that entrance, we're building stone slopes that tie the basement into the ground level and create a solid, natural-looking entryway. These stones will also act like retaining walls, helping the slopes hold their shape and stay stable over time. This backhoe doesn't have a tilting bucket, so working with stones is a lot tougher. That means plenty of manual labor. Each stone is massive, and every single one has to be adjusted and fitted into place as tight as possible. It's basically like building with giant Lego, only these pieces weigh a few hundred kilos each, and none of them fit the way you want. It's slow, it's heavy, and it's stubborn work. Right now, the stones don't look great, muddy, gappy, and rough. But that's just the start. Once both slopes are locked in and cleaned up, the entrance will look completely different. We're not just dropping these stones straight onto clay. First, we dig out the clay where the slopes will sit, then we got a full lorry of sub-base material that we'll be using to help us set these stones in place. Clay moves a lot. When it gets wet, it swells. When it dries, it shrinks. If we left the stones on top of it, they'd sink and get pushed out of position every season. The sub-base creates a solid layer underneath. It gives the stones proper support, so they stay where they're set instead of sliding or shifting over time. We can only go about halfway through the slope for now, because the stone facade is only half built. We'll show a bit more of that later in this video, but for now, let's get back and finish the concrete slab. Now we need to build the edge formwork for the slab thickness, so the concrete doesn't spill out. We're reusing the same OSB from the wall formwork, and luckily we never sealed the top holes. That means we can just drill straight through the OSB and run threaded rods across to the other side of the wall. Once all the edge boards are in, we'll cut them down to the actual slab thickness. But before that, these rebars sticking out of the walls need to be bent down. Right now they're just in the way, but soon they'll tie directly into the slab's rebar mesh. We left them sticking out from the very beginning of the wall mesh, and now by bending them over, they'll lock the walls and the slab together into one solid structure. To get the right height and a straight edge, we use a chalk line. Just pull it tight, give it a snap, and you're left with a perfect guide to cut along. And off we go with the circular saw. The straighter this cut is, the easier it's going to be to level the top of the slab. But it's not easy. This line is pretty long, and we're free cutting without a guide rail. Came out alright, not perfect, but it'll do the job. For the bottom mesh, we're using 18mm rebars. And these aren't easy to bend, especially since we've got to match the slope on both sides. We measured from the edge of the formwork to the center point, then bent the bar there, leaving the other side longer for later. Once these bars are in place, we can finally see how much needs to be cut off. And for 18mm steel, we're not pulling out the little toys. This is a job for the big angle grinder. The small grinders just don't cut it, literally. You'd be standing here all day. With the big one, it's sparks flying, steel screaming, and the job gets done. Heavy steel needs heavy tools. Simple as that. To tie these 18mm beasts together, we're laying 10mm rebars across the top. The real work is done by the bottom bars. They're carrying the load, but the 10s lock everything into one solid mesh. Think of it like muscle and tendon. The 80s are the muscle, and the 10s keep it all connected and moving as one. We're making a 15cm eye, basically spacing the bottom and top rebars every 15 centimeters. And all this tying is done by hand with a homemade hook. We thought it would be quick, but it took way longer than expected. By the time we realized it wasn't worth renting a tying tool, half the mesh was already done. But the bright side is, tying by hand pulls the steel tighter and makes the whole mesh stronger than those tools ever would. The bottom mesh is finally done, and now it's time to move on to the top mesh. This part's going to be a lot easier, because the entire top layer will be made from 10mm rebars. And this top mesh will have a 20cm eye. Since the slab is 20 centimeters thick, one mesh layer wouldn't hold all that concrete. That's why we need this top layer, basically to keep the top of the slab locked together. With both meshes in place, we lift the second layer up using rebar chairs. That gives us a 6cm gap between the meshes, just enough for the concrete to flow through and lock them together. Now, before pouring, we need to clean all the mud off the rebars and the formwork. It's been raining almost non-stop for weeks, so keeping mud away was mission impossible. but it's important. If concrete goes down on dirty steel or muddy formwork, it won't bond properly. That means weaker concrete and less grip on the rebars. With everything ready, the pump truck rolls in, followed by the concrete truck. 8 cubic meters loaded up. Now we can start pouring. The trick is to spread it as evenly as possible because the more even it goes down, the easier it'll be to level afterwards. But pouring evenly isn't easy on a slope. The concrete just wants to run downhill. That's why we've got a string line through the middle of the slab, giving us a reference to keep everything poured evenly. With the last concrete poured, we grab a rake and go around the slab. On the slopes, the concrete gets pushed down while vibrating, so we spread it back into place. Then we take a long screed and pull it across the slab. First from the middle down to one side, then from the middle down to the other. This step evens out the surface and sets the base before finishing. And for the finishing, we're using a polystyrene float. It's light, easy to handle, and perfect for closing the surface after screeding. We don't need perfection here, since it's all going to be buried underground. The slab is now ready to cure, and we'll leave it for at least 3 weeks before doing anything on top. But now we can jump to finishing the stone slope. First, we need to clean all the dirt off these stones and clear out the joints. That way we can fill them with concrete so rainwater and mud can't wash through. These joints will still crack eventually, since the stones are laid straight on the ground, even on this subbase. But that's the idea. Over time, the cracks will settle, moss will grow in, and the whole entrance will blend in naturally. To get there, we're making sure every joint is packed solid with mortar, so there are no loose spots or hollow gaps inside the joints. And once the mortar dries a bit, we take a wire brush to clean the excess off the stones and smooth out the joints. That's it for now with the stone slope. The joints are packed and done. We'll come back to finish it once the backhoe loader is back to bury the basement. But for now, we'll be moving on to the stone facade at the front. These aren't bricks, they're full stones. Heavy, awkward, and stubborn. Getting them in place is pure muscle work. You can only lay 1 layer a day, because every course needs to be backfilled with concrete. And once it's backfilled, we set in steel rebars to tie the concrete wall together with the stones. Then we cut off the bits of rebar that stick out too far. That way, when we set the next stone in place, the steel won't get in the way. Now we chuck in some mortar, spread it out, and off we go with another layer. Each stone has to be hand-picked and set carefully to get the best match for the joints as we build it up. Once a layer is in place, we wait a day for it to set. Only then do we backfill behind the stones with concrete so they don't get pushed out. That backfill ties the basement wall to the stone wall, locking them as one. And we need a full surface at the back before adding the next layer. With every stone a different shape, you can't stack multiple rows at once and leave empty gaps. Then we compact this backfill concrete with a stick, not a vibrator. Vibrating could push the stones out of place. Once the backfill is compacted, we level the top of the concrete to match the shape of the stones. That way, the next layer needs much less mortar and it's easier to set the stones in place. Now it's time for the stone arch. We're reusing the template from the wall pour. It goes back up to hold the stones in place until everything sets and locks itself in. With the template guiding us, each stone follows the curve as the arch takes shape. One after another, every piece has to be set just right because the weight of the whole entrance will press down through this curve. It's slow work, but once the last stone is in, the arch will stand on its own. Once the arch layer is done, we tie the stones to the walls. Rebars stick out of both, joined with horizontals across the layer, then tied with steel wire to lock it solid before the concrete is poured. All the rebars are tied together. Time to backfill. But we'll save that for later. Right now, let's strip the slab formwork and see how it came out. We're starting by stripping the outside first. We couldn't unscrew the support planks, so we're just ripping them off. We left the OSB on longer to slow the drying of the concrete. In that time, it stuck tighter to the surface, but because we'd oiled everything, it came off smooth with no honeycombing. Now, let's hope the inside of this slab came out alright too. We start by releasing the acro props, not taking them down yet, just lowering them a bit. That way the pressure comes off and the beams can be released from the slab. We can't take all the formwork down at once. If we did, the whole structure would drop on us in one go. These boards and beams are heavy, and once they start falling, you can't stop them. That's why we strip it carefully, one section at a time, keeping control as we go. The boards are still stuck to the slab, and that's actually good for us. It makes the work much easier. This way we can keep control, instead of everything dropping down at once. We can strip them off slowly, section by section, keeping it safe and under control. Putting these marine ply boards up was quick and easy. Each one covers a lot of space, as it's bigger than standard sheets, so they went up fast. But taking them down over your head, that part's not nearly as easy. Here's the final result inside the basement. The slab came out solid, no honeycombing, and all the concrete pouring is finished. With that done, we can jump back to working on the stone facade. We've got the tracked dumper loaded with concrete for backfilling the stones. Lucky we had it, since the path up to the facade is uphill and uneven. And we're backfilling these stones. It's getting trickier to fill as we go higher, but every layer locks the facade tighter. The arch layer is done, and we're nearly at the top of the slab, but we still need to build the stonework a few layers higher. That way, once this slab is buried underground, the stones will act as a retaining wall to hold everything in place. And we're on the last course of stones, the final ones going into this wall. It's been quite a challenge, and we finally finished the stone wall. Now we can tie the back of the stones, and with that, the wall will be fully complete. But the backfill here is trickier. We can't just pour concrete in, it has to be shaped freehand, without formwork. For these top 2 layers of stones, the backfilling is even harder, because it has to be done above the slab. The concrete needs to slope down from the top of the stones towards the slab, so water drains properly. This angled backfill also works as a retaining wall, holding back the clay so it doesn't push the stones out of place. We're leaving it about 5 centimeters lower than the stone tops. That way we can cover it with earth, and when the grass grows, it will run right up to the stones for a smooth finish. Formwork here would be almost impossible with the angle, so we're shaping it freehand, and it's coming out alright. Now we're making the stairs into the basement. We raised the entrance by 50 centimeters to avoid a steep path, and that's why we need stairs to step down once inside. First, we set the piles that will hold the stairs and the entrance platform. The outside pile needs to be deeper so frost can't reach the bottom and shift it. We drilled the rest by hand since I forgot the extension, aiming for 1.2 meters. In the end, we hit 1.4. Went deeper just because it was too easy. Now all that's left is to fill these piles with concrete, locking them solid so the stairs and platform stay in place. These piles don't need that much strength, so we're using leftover rebars from the build. We leave them sticking out, giving us points to tie the mesh later and lock everything together. All the piles are filled, and we'll let them set. In the meantime, we're jumping onto the slab. Plenty of work waiting there. Now we're making a brick chimney imitation for the basement air vent. Ventilation is important down here. Without it, moisture builds up, walls stay damp, and the air goes stale. The first section, which will be underground, we're casting from concrete. To lock it into the slab, we drill in 4 vertical rebars, then we tie them together with horizontals. Then we make a simple 40 by 40 centimeter formwork box out of leftovers and fix everything with screws. There won't be much pressure here, so no need for heavy formwork. To keep the middle hollow, we used a 110mm drainage pipe wrapped in pipe insulation. That way, once the concrete sets, the pipe can slide out easily, leaving a clean opening for the vent. We're only filling this formwork 50 centimeters above the slab, since later it'll be covered by soil. Once the concrete's in, we take a small hammer and give the boards gentle, frequent taps. It helps the mix settle tight and keeps the edges clean. The concrete's set, so let's see how it came out. Looks pretty sweet, no honeycombing. Only thing, I missed the height a bit, ended up 10 centimeters lower than planned, but we'll fix that difference with the bricks. To fix the height, the first layer will be white silicate bricks. We don't have enough of the old bricks, so they're hard to come by, and these white ones will be covered anyway. And now it's time for these old, crusty, chipped bricks, the ones that will make this basement look like it's been here for decades. Laying these old bricks is a different kind of challenge. None of them are the same, edges are chipped, corners missing, so every brick has to be hand-picked and adjusted to fit the line. It's slow work, but that's what gives this basement character. No 2 joints look the same, and that's exactly the look we're going for. And yes, you can already see the waterproofing on top of the slab, but I'll show you how that got there once we finish with these bricks. Before we finish, we need to shape slopes around the bottom of this chimney. Torch-on waterproofing can't just bend straight up at a 45-degree angle. It could crack or pull away over time. So we're shaping the bottom slopes with concrete, adding a few rebars to hold them in place, and doing it all freehand. With the brickwork finished and the slopes shaped around the bottom, the chimney will look like it's been standing here for decades once this slab is buried. And now let's jump back and I'll show you how we got this torch-on waterproofing in place. For the first sheet, we overlap from the top of the slab up onto the wall, and we always start from the lowest point. That way every next sheet overlaps the one below it, so water can only run down, never underneath. We roll out the sheet across the slab and cut it with a 15 centimeter overlap onto the wall. That way we don't have to move the whole roll. Once it's set in place, we roll it back to the middle and start from there. Easier to work with smaller sheets. Now it's time to heat and install the waterproofing. Whoa, not that quick. Just lost the roll a bit. And this is my first time doing this waterproofing, so here's what I've learned. Use steady heat. Warm it until the bitumen shines and bubbles slightly. That's when it sticks. If it's dull, it's not enough. If it smokes, it's too much. The trick is slow work. Heat a bit, roll a bit. Once the main surface is done, we fix the 15 centimeter overlaps. At the corners, we cut them so each layer sits over the other neatly. The key with overlaps and angle changes is simple. Always lap them so water runs over the joint, never into it. Sheet by sheet, we're covering the entire slab. Each piece goes down carefully, overlapping onto the next one so the seal is tight. For this slab, 1 layer of torch-on waterproofing is enough. Once it's buried under soil, it'll stay protected, and with the built-in slopes, water won't sit on top anyway. Those slopes make sure water has nowhere to sit. It runs straight down and off the surface instead of pooling on top, Every overlap gets at least 10 centimeters of cover, so even as the sheets expand and contract with the heat, the joints stay sealed. It's slow, steady work in real time, but sheet after sheet, the whole slab locks under one continuous waterproof layer. And with all the waterproofing done, this basement is ready to be buried underground. But before we cover it up, let's go back to making the stairs. First, we cut 3 planks out of 15 by 5 timber to match the length of the stairs, 1.2 meters. Each step will be 15 centimeters high, and the 5 centimeter thickness stops the concrete from pushing the frame out. Once the planks are in place, we set up the sideboards to fix them too. For this, we're reusing OSB from the previous pours. When setting the planks, we line them up so the bottom of the higher plank sits flush with the top of the lower one. That way the concrete settles clean, forms an exact 15 centimeter step, and doesn't leave a nasty trench mark once it sets. With the formwork in, we start the rebar mesh. Long bars are drilled into the basement wall on one side and tied into the stair piles on the other, holding the mesh at the right height. Across them, we tie cross and diagonal bars, giving each step its own mesh layer and extra strength at the front edges. At the top, the rebars run into the entrance platform, so once poured, the stairs and platform become one solid piece. We can't fully finish the entrance rebar until we install the channel drain at the front of the entrance. It will stop rainwater coming from the path and from the entrance platform, since we're sloping the platform back toward the path. First, we pour a concrete bed for the channel drain to sit on. Then we cut the drainage pipe to the same height as the bed, so the trench can connect straight in and the water has a clear way out. With the bed set, we can install the trench. We're setting it to the same height as the existing concrete at the basement entrance, since the entrance platform will be 10 centimeters higher. That gives us a 10 centimeter slope from the basement door straight into the trench. Then we pack concrete along the sides of the trench, leaving about 4 centimeters from the top. That locks the drain in place from all sides so it won't move. And with that done, we can finish the mesh and get ready to pour the stairs. But before we can pour, the mixer needs some love. It's been spinning for 3 years straight, so the bearings finally gave out. We swapped them, and now it's time to put the drum back in place. And we can finally start the pour. These stairs take a lot of concrete, so we start from the bottom and work our way up. They're solid, no hollow space. More work, but once set, they'll be rock solid. Good thing the mixer's got new bearings, it's in for a workout. Once this stair section is full, we vibrate it before pouring more. If we left it, the vibration would just push the concrete out. This way it gets time to set and we can level the steps before moving on to the platform. After vibrating, some concrete gets pushed down and overflows from the steps. First job is to clean all of that out. Then we take the hand float and even the surface, bringing the concrete level with the top of the planks, so every step sits right. For the final finish, we switch to a putty knife. The key is to hold it horizontal, let it glide on its own, and not push down. That way it smooths the surface clean and gives the stairs a sharp finished look. For the top stair, we switch to a leveling screed bar. First, we pull it flat to make sure the top is perfectly level with the door threshold. Then we screed the concrete on an angle from the door down into the trench. That way, the entrance platform forms the slope needed for drainage. For the final finish on the platform, we use a concrete finishing trowel. It lets us smooth out the last rough spots and bring the surface to a clean, even finish. And with that, the stairs and platform are finished, and we can finally bury this basement for good. We start by bringing in a load of sand onto the slab, then spread it out with a rake before the next load comes in. Step by step, the whole surface gets covered in an even layer, and this layer isn't just for looks. The sand does more than drainage. It protects the waterproofing from clay and stones, spreads the load evenly, and makes sure no water sits on top of the slab. With the slab covered in sand, we shape a trench out of clay about 30 centimeters away from the basement walls. That gap then gets filled back in with sand, right up to the slab sand layer. This way the whole system connects. Water running down from above can move through the sand at the sides and drain naturally into the sand layer under the basement. With the trench filled and the sides tied back into the sand layer, we can finally start tackling the clay pile that's been here since the very beginning of this basement. On top, we need a 50 centimeter layer of clay to keep winter conditions out. It works as natural insulation, but we're putting in 60 centimeters since clay is hard to compact. Over time, it'll settle down on its own to the right thickness. To help us bury the basement, we brought in a mini excavator. It's light enough to drive right onto the slab, spreading clay into the areas the backhoe can't reach. This little machine might not look like much, but here it's a lifesaver. One side also needs to be sloped with the mini, since there's a fence running right along the edge. Taking the backhoe there would be way too risky. Bit by bit, the basement is getting covered. Every load of clay shapes it more until soon it'll look like there's nothing hidden underneath at all. But before we can finish burying it, we've got to complete the stone slopes at the entrance. We're setting the last stones into the slope. At this stage, every move has to be careful. The stones already jointed in place can crack or shift out of line with even the smallest knock. Then we backfill, packing the stones in solid all around with sub-base material. That way they're locked from every side and stay firmly in place. With one side of the slope finished and locked in place, we move over to the other side. The process is the same, backfilling, setting each stone, and packing it solid until the slope is complete. Once all the stones are in place, we give the slope a good wash with the jet washer. It clears the dirt and mud off the surface and cleans out the gaps, leaving the joints ready to be filled. Then we start backfilling the joints with concrete. Every gap is packed tight so nothing's left hollow inside. This locks the stones together, stops water and mud from washing through, and makes sure the slope will hold its shape over time. With the slope set in place and all the joints packed, we can finish burying the basement. Just like that, all the effort we put in is hidden underground. The only thing left visible is the entrance. But before we can call it complete, there's still one last job waiting for us, the stair railings. First, we make the metal plates and chuck them onto the threaded rods that were set in during the pour. Next, we cut 6 square pipes to the height we want for the railing. These serve as the vertical posts, and we weld each one firmly to the base plates so the whole frame stands solid. After that, we anchor an L-shaped metal piece into the wall. This gives us a solid point to fix the top rail where it meets the wall. Now we can finally start fitting the top railing. First step is tack welding everything in place. Tack welds are small welds made just to hold the pieces together temporarily. We line the rail up with the posts, check the angles, and put a short weld on each joint, just enough to stop it from moving while we work around the rest. The idea is to lock the whole frame together without fully committing. If something's a little off, we can still adjust it before running the final welds. So it's slow and careful. Line, check, tack. One by one, every joint gets pinned until the railing is held solid in place. With everything tacked in place, it's time to weld for real. We go joint by joint, laying full welds all the way around. Bright arcs and steady passes melt the steel together, locking the whole railing solid for good. Now we take the angle grinder and smooth out every joint. Once the welds are ground down, the railing looks seamless, like one solid piece of steel. And with that, the railings are finished, and the basement is complete. This was one hell of a project, and it's finally done. But we're not stopping here. More builds and projects are already on the way, so make sure to subscribe and follow along. Drop a comment. What do you think about this basement build? Would you take on something like this yourself? Your feedback keeps these projects alive, and I'd love to hear your thoughts before we jump into the next one. We came back after a while to see how the basement settled. Grass is already starting to grow, and all that effort is now hidden under a green cover. What's left is the stone entrance and the wooden door now in place. It came out pretty sweet. Thanks for watching, and stick around. More builds are on the way.